Hello and welcome back to Orbit by Risa Astronomy. I'm Anish, your host for the day. Today we are going to be talking about something that's been making a lot of news in the social media and in the newspapers, that is Atlas 3I. Uh, what we do know about it is that it is an interstellar comet. So if you don't want to listen to the end of the podcast, I can answer those three questions that we've been asked during our camps and during phone calls with people. One, is it an alien object? Two, is it going to hit the earth? And three, the most common question is, can we see it? Well, I'll give you the answers for that right now, and then you can hang around for the detailed explanations. Number one, it's not an alien object, unfortunately. We know that it is a comet, but it looks like a comet, it walks like a comet, talks like a comet, so it is a comet. The second thing is, it is not going to hit the earth. The probability of that is near zero. And thirdly, can you see it? Well, it depends on what you mean by see, but long story short, you'd be disappointed. Now, let's dive into what's going on. Before we really talk about comets and about how we know something is interstellar, I think what has put people off is the name. When someone looks at it, the name itself, Atlas, the program, is about having a lot of telescopes. Right now it has about 5 telescopes in different places in the world, and I have to asteroid terrestrial impact last alert system. That's a mouthful, so it sounds deadly, and that's also the reason why a lot of people panic when they hear that NASA has suddenly unleashed the last alert system on this comet. Well, that's not true. The Atlas program is meant to be scanning our skies every day, and it is supposed to be looking at smaller threats. We have other programs like Pan-STARRS, and earlier it used to be called the WISE program, and now it is called the NEO-WISE program, and that is actually looking for larger objects. But in general, when an object is identified by a particular program, then that object gets that name. So if Pan-STARR sees that comet or asteroid for the first time, then it is usually called something Pan-STARRS or something NEO-WISE. So this is just the name Atlas. The 3I just means that it is the third interstellar object. The first one was found, I think, in 2017, which was just 2 years after the Atlas program was launched. And then the second one was in 2019. It was a bit larger object. And this is the third one. So that is about the naming convention. Now, what was detected, right? That's really important. So let's dive into that. First thing we need to understand before we go into orbital mechanics is to just visualize how our solar system looks like. Imagine you are drawing the solar system with the sun and all the 8 planets on a piece of paper. You do that, and let's say that you take that piece of paper with the 8 orbits drawn on it, and then you place it in space. Now, this means that what we're depicting is all of the planets and the sun are on one plane. Though there is a lot of space literally in the solar system, all the planets are on the same level or the same plane. Not only the planets, the asteroids, the moons, they are all in the same plane. So this Atlas program is usually looking for things that are there on this plane. We call it the ecliptic. And that's the path the sun also takes during the daytime, and the moon also takes at night. Is the same thing. It's the same path. which is more or less, I mean, there is a little bit of difference between one and between one planet to the other. Not all of them are 180 degrees on the same plane, but it's more or less on the same plane. So that's one thing you need to understand before you try and unlock the mystery of the Atlas 3I. Now, while the Atlas program was scanning for this in July, they noticed an object moving against the background stars, and that is how they found out that this is something that is not in the database, and immediately they assigned a number to it, and that number later became 3I once it was known that it was an interstellar object. Now let's come to how we know something is an interstellar object, and it's pretty much a matter of figuring three things out. One is the eccentricity. Now, I know we are all eccentric, but in the case of orbital mechanics, we talk about orbital eccentricity. Now, if you take a circle is drawn with one focal point that is in the center, and then you draw around a circle. For an object that is going around the sun, if it is going around it in a circle, then that would be the orbital eccentricity would be 0. Alright, it's as simple as that. Now, if the value is between 0.1 and 0.99, then it means that the circle is squished on two sides, on top and at the bottom. So you take a circle and squish it, you start getting an ellipse. And the more you squish it, this number goes up from 0.1 all the way to 0.99. Earth is almost on this scale, almost on a perfectly closer to being a perfectly circular orbit. Whereas, for example, if you think of Halley's Comet, it's not an interstellar comet. It has very high orbital eccentricity, but it is still a closed loop. All right, it is an ellipse. Now, if this number hits 1, then it means that it's like the rubber band, right? The two ends of the rubber band have broken. The orbit is no longer a closed loop. That's what the orbital eccentricity of 1 means. Now, you might have already figured this out. If the orbit is not in a closed loop, that means that it is going to come in and go around the sun, and it will never repeat that path again. So that we call a parabolic orbit. All right. The last the first object that was found, which was only a 100-meter asteroid, that had a parabolic, it entered in a parabolic orbit. That means that we were never going to see it again. But there are also cases where the value is way higher than 1. And if in this case, the 3I has an orbital eccentricity of about 6. And that means that it's a hyperbola now. And we will never see it again. All right. So that's how we know that this has come from outside the solar system. That is clue number 1. All right. Now, clue number 2 is, what is the velocity of this object if you ignore the effect the sun is having on the object? That means how fast is that object going by itself? Because if you go closer to the sun, there will be what we call as a gravity assist. So there will be some sort of pull and some sort of increase in speed. Normally, for comets like, let's say, Halley's Comet, the technical term for it is the hyperbolic excess velocity. That is for a comet which is within our solar system, that's closer to 0. Now, this one came in at an excess velocity of about 60 kilometers per second. That is insanely fast compared to what we would expect if the comet had come from within our solar system. So that was our second clue, that it was not a comet that originated from what we call as the Oort cloud. The Oort cloud is something that is like a huge shell, like an eggshell, that covers the solar system, our solar system, on all sides, and then you get comets coming in from them periodically. So that is the second thing. And well, one thing was odd about this. Generally, and you remember the plane of the solar system that I was talking about. Generally, the comets, the first one that we found out, the asteroid, the interstellar object that had more or less come in from the top, and it went around the sun and it went back up. But this one is a little bit different. This Atlas 3I is almost level to the plane of our solar system. Okay, so imagine the solar system is 180 degrees. This is 175 degrees, except it's going in the wrong way. If all the planets are going clockwise, this guy is coming in anti-clockwise. That's the only difference. And it has a huge orbital eccentricity. As I already said, it's a hyperbolic orbit, so it is not going to come and go in the same path. All right. So what it has done is, imagine I am the Earth and I'm looking at the sun. This has come all the way from my left, far out, gone out around the sun, and then escaped to my right. But it is not coming towards me anymore. It is just going away. So it's almost like an obtuse angle, right? So that is what the orbital inclination is. So these three things we could find out. The inclination doesn't matter. The inclination could be anything, but the other two things tell us that it is an interstellar comet. All right. And then how do we know it's a comet and not an asteroid? Well, that is simple. It has an ion tail. It has all the outgassing that it does. What is interesting is that this particular comet is mostly carbon dioxide, ice. There's carbon monoxide as well. And it's outgassing what looks like nickel. So that's pretty interesting. And that's what a lot of people are not happy or not happy with the explanation that was given by NASA. And they say that there is some sort of tech on this, but we haven't heard any signals from this. There is really no change in the acceleration other than the impact that the sun is having. There is absolutely no change in the acceleration. And even if it was an interstellar object with alien technology, you'll have to think about the timelines here for a bit. All right. Imagine that this was an alien craft. Now we know that it has come from somewhere in the Sagittarius region, that is in the central portion of our Milky Way. We know that looking at the angle that it has come into our solar system. But has this comet originated there? There is no way to say that, because this comet is about as old as or even older than the Earth itself. So you can imagine over the last 5 to 7 billion years, how many stars systems it would have taken this sort of a gravity assist and changed direction ever so slightly. So there's no way. We just know that right now it is coming from around the Sagittarius region, but it could be shuttling the whole solar system, the whole Milky Way for a lot longer than that, and we have no idea where it originated from. It just got kicked out of its solar system, and it's been traveling ever since. So if it's going to write a book, it'll have a great story for sure. So what is the other thing that we need to know about why it is not an alien spacecraft, right? And that's pretty simple, just the math of it. We have a way, the nearest planet from us, the nearest star from us is something called Proxima Centauri, which is only 4 light years away, which means that if you could travel at the speed of light, which is 3 lakh kilometers a second. Remember, the comet was only going at 60 kilometers a second. The speed of light is about 3 lakh kilometers per second. And if you could go at that speed, you would reach Proxima Centauri in about 4 years. Okay, so what about this comet? Well, this comet would take about 20 to 25,000 years to reach our nearest star. So the point here is that if it is alien technology and if it's going to take 22,000 years just to go to the nearest star, and imagine coming from the center of the Milky Way, how long that is going to take. And is there any alien species that lives, well, if there is, then they would have to live for probably a billion years for all of this to make sense. Otherwise, it is traveling too slow. That is the whole point. That's well. Now, where did the alien theories come from? Every time we had extraterrestrial visitor, and that's thrice now we have had these alien theories come up. But particularly for this, I think there are, there are three main points of contention. One is something that they call is a heartbeat. Okay, a heartbeat meaning it looks like every 16 hours this something is flipping. There is a periodicity to this. Of 16 hours, the brightness goes up and comes down. It's almost cyclical. Now, people say, "Oh, look, that is the engines firing." That's not true. Most comets are not completely spherical, and they also have an orbit. And sometimes, some part of the nucleus, some part of the main core of the comet, could be a different irregular shape, and that's why when it is tumbling, we get varying brightness. The second thing that has happened is, which is another point of contention, is the inclination that it came in, which I was explaining earlier. It almost came in with the same, on the same plane as the rest of the solar system objects, that means as the planets. So people said, okay, that looks intentional. Well, it can come in anywhere. I mean, there is nothing stopping it from coming on exactly the same plane as our solar system. This intention has nothing to do with it. It is random. And the second thing is that we only have a sample size of 3. We only have 3 interstellar objects. That is not enough data to make up our mind about intentionality. And I think the biggest problem that came up with the 3i was when it was discovered in July. That coincided with also what NASA shut down. They had the government shut down. So there was a vacuum of information from NASA, and people jumped onto it saying, hey, look, NASA is silent. That means something is up. And that's typically the trope that we use in movies, right? So that helped play into some of these conspiracy theories. But as I said in the beginning, it looks like a duck, walks like a duck, talks like a duck. It has to be a duck. And this one is definitely a comet and nothing else. All right, before we sign off, here is a tip. If you do want to observe this, December 19th may be the closest approach, but it is not the only day that you will see it. You should be able to see it by now or a couple of days after that also. It will be in the constellation of Leo, and early morning, maybe around 4 to 5 o'clock, may be the best time to see it because Leo will be overhead by then. Definitely do not try with from the city, and not with the naked eyes. You need a telescope of at least about 12 inches, I would say, and maybe a little bit smaller if you are in a very dark place. Like Coorg or the Himalayas. All the best for that, and signing off. This is Anish, and look forward to talking to you in our next episode